5th, 4th, 3, 2, 1. Interactive Magnetic Impedance Kit, IMI Kit. A project created by Zarina Ismail, a lecturer at Polytechnic Tuanku Sultana Bahia Department of Electrical Engineering. The purpose of this project is to assist student in comprehending fault calculation, which is a subtopic of the Power System Protection course that requires knowledge of the impedance diagram. Struggling with impedance diagram concepts? Need a better way to learn? IMI Kit is the solution. The Interactive Magnetic Impedance Kit, IMI Kit, represents a groundbreaking innovation in the field of electrical engineering education, specifically designed to enhance the understanding of power system protection. This interactive learning tool addresses the common challenges faced by students in grasping complex concepts such as fault circuit analysis and impedance modeling. By integrating hands-on experiences, the IMI Kit allows students to visualize and manipulate electrical circuits, fostering a deeper comprehension of theoretical principles. Through collaborative problem-solving activities, students engage actively in their learning process, bridging the gap between theory and practice. The IMI Kit not only improves students' analytical skills and confidence in handling real-world electrical issues but also prepares them for academic assessments. With its unique approach to teaching, the IMI Kit is poised to revolutionize the educational landscape, making learning more effective, engaging. Understanding power system protection is crucial for ensuring the reliability and stability of electrical networks. However, students often face challenges in converting power system circuits into impedance models. Many students find it tough to visualize circuit conversions. Feeling lost in fault analysis? Introducing the Interactive Magnetic Impedance Kit, an innovative teaching tool designed to simplify learning through interactive and practical engagement. The IMI Kit is a hands-on learning tool that simplifies understanding of impedance models and fault analysis. The IMI Kit is designed to, first, provide a tangible, interactive way to understand impedance-based circuit models. Second, offer hands-on learning experiences for fault analysis. Third, reduce calculation errors by visually guiding students through circuit configurations. And lastly, enhance the overall effectiveness of power system protection education. Flowchart of innovation idea. First, identify problem. Do some research and analysis. Define objectives. Design IMI Kit. Prototype development. Then we get feedback collection. If negative, we design again and redo a prototype. If positive, we direct the refinement and final production. Lastly, evaluate effectiveness. How it works. The kit consists of magnetic visual boards of components such as generators, transformers, impedances, loads, transmission lines, bus bars and so on. For the teaching staff, it is large in size, while for students it is small in size and will have more impedance components. Each component is designed in magnetic adhesive form to allow for flexible circuit rearrangement. The IMI Kit has received an Intellectual Property Registration Certificate from MIEPO under the Copyright Act 1987. Let's take a look at the usage in the teaching and learning session. From this question using IMI Kit. Then to the impedance diagram. The exercise in the class. Students will work together with their group members to solve the problems collaboratively. All happy? With the IMI Kit, learning is more effective. We make grasping fault analysis easier. Using the IMI Kit brings clear advantages. Visualization of circuits helps pupils better explain the circuits of power systems. Hands-on training. Using magnetic components, students can construct their own circuits, enhancing their practical knowledge. Active education. Students can investigate several failure scenarios as part of the kit's problem-based learning approach. Increased precision. Students may reduce calculation errors by thoroughly understanding concepts. Impact of student. Deeper understanding of fault calculation concepts. Practical experience in applying theories to real situations. Better preparation for exams, especially for fall-related questions. Enhanced creative thinking and problem-solving skills. Increased confidence in handling fall-related situations. Impact on instructors. Improvement in teaching methods with more interactive sessions. Ability to provide more accurate feedback on student understanding. Enhanced collaboration with students during exercises. More effective assessment of student progress. And creation of a more positive and engaging learning environment. Impact on institution. Improvement in overall education quality. Development of students' practical and technical skills. Increased competitiveness in vocational education. Support for professional development of educators. And enhanced student engagement and motivation. Looking ahead, adding digital features to the EMU Kit could take learning to the next level. Imagine students scanning a QR code to check their understanding, or a mobile app that helps them track their progress after each activity. This kind of integration would not only make the learning experience more engaging and personalized, but also give lecturers a clearer picture of how well students are grasping the material. It's a small step toward a smarter classroom, and it helps prepare both students and teachers for a future where hands-on and digital learning go hand in hand. One invention that has the potential to significantly enhance students' comprehension of fault analysis in power systems is the Interactive Magnetic Impedance Kit. This kit can address the drawbacks of conventional teaching methods by using an interactive approach. Students who use these technologies not only improve their learning results but also acquire useful skills that are in line with industry demands. This kit is an advancement in electrical engineering education since it equips students to handle the actual difficulties in the field of power system protection.
Sounds exciting?
The following are part of the list of references involved in this innovation. EMU Kit, explore it today and enhance your learning experience. That's all from the EMU Kit. Thank you for watching until the end.